Okay, and finally for 1c, the integral of secant cubed is what we're going to be doing here. This one's a very common problem, and I'm sure you saw this in your book. It's one that is something, honestly, you might even want to memorize. It is a little bit long for that. But doing this by integration by parts is very doable. What's tough to determine is what you should call u and dv. So in this case, what you actually want to do is kind of take the forethought in knowing some of your trig integrals to choose this. So keep in mind, for integration by parts, your u and dv, their product has to give you what you started with. Now, in the cases where you have two separate types of functions, usually that's pretty obvious. You have one and another. But that doesn't mean you can't just split this up so that the product is secant cubed, and in fact that's what you want to do here. You should know that the derivative of tangent is secant squared, so it would make sense if we call our dv secant squared x dx, because that antiderivative is really simple, and u can just be secant. So this is fine because our u times dv does give us our original integral. We just happen to split up one function instead of having two separate functions. But the important part is that the product of these two gives us what we started with. That's fine. So now let's do our integration by parts. The derivative of secant is secant x tangent x dx. And the antiderivative of secant squared is tan x. So if we do our integration by parts, let's see what happens. So we have uv first, so we get secant x tangent x minus the integral of v times du, which in this case would be secant x tan squared of x dx. So in this case, we can actually do a couple of things, but the best one would be to change tan squared into its secant squared form. So let me rewrite this line, but with that substitution, and let me write what this is all equal to, in fact, on the left. So we have the integral of secant cubed is equal to secant x tangent x minus, so we're going to write this as secant x, and instead of tan squared, recall that tan squared is secant squared minus 1. So we have secant x times secant squared x minus 1 dx. So what do we get? I'm not going to keep writing the left side here. What do we get when we distribute that? So we get secant x tan x minus the integral. So this would be secant cubed, which if you notice, we already have over here. So this is going to happen kind of like in the previous problem where we have an integral that we can add over. We're going to get secant cubed minus secant. So instead of writing them separately, let me write them as two different integrals. Keep in mind that second one is plus because I'm subtracting this entire thing. So when I subtract the integral of minus secant, which is what I get when I distribute that, it becomes plus. So now I can add this over to the other side, and I get 2 integral of secant cubed x. What's remaining on the right side is secant x tan x plus the integral of secant. Now the integral of secant is something you should just memorize, and it's ln of secant x plus tangent x. So finally all we need to do is divide by 2. So that means that our integral of secant cubed is, and in this case you probably see it most likely written just with halves in front of each one, 1/2 secant x tan x plus 1/2 ln secant x plus tan x plus c. And that's your answer there. So in this case, we still had to do like in the previous problem, recognized that this was an integration by parts problem, that we had to add over the secant cubed to make 2 of our same integral. So if you ever end up with an integral of the same function that you're trying to integrate in the first place, always add that over, get what's left. But the deciding factor was at the beginning, knowing to split this into secant and secant squared, and that's just because secant squared is a much easier quantity to deal with. So recognizing these types of things are what are going to help you with these problems.